In this example, we want to determine the derivative of f of x equals sine x divided by cosine x using the quotient rule, which is given here below in red. But before we do this, we should recognize that sine x divided by cosine x is equal to tangent x. So we could rewrite this function as f of x equals tangent x, and we know the derivative of tangent x is equal to secant squared x. So after we apply the quotient rule to find this derivative, we know the derivative function should be secant squared x. But this is good practice on applying the quotient rule to find a derivative. So to apply the quotient rule, we'll let the numerator equal f and the denominator equal g. So the derivative of f divided by g is equal to g times f prime minus f times g prime divided by g squared. So to determine f prime of x, let's start with the denominator. The denominator is just going to be the denominator squared, or g squared, so we'll have cosine squared x in the denominator. Our numerator is going to be g times f prime minus f times g prime, or the denominator, cosine x, times the derivative of the numerator. The derivative of sine x is cosine x, minus f times g prime, or the numerator, times the derivative of the denominator. The derivative of cosine x is negative sine x. So when we simplify this, the denominator is going to stay the same, and our numerator is going to be cosine squared x, and here we'll have plus sine squared x. Notice we had minus sine x times negative sine x, which becomes plus sine squared x. But cosine squared x plus sine squared x is equal to 1, so we have 1 all over cosine squared x, but 1 over cosine squared x is equal to secant squared x. So this does verify that we have the same derivative function, which we expect whether we use the quotient rule or whether we write the given function as f of x equals tangent x.